So all of you can see my screen, right?
Yes, it's visible.
Okay. So as I said in the WhatsApp group too, and even before before the phase one ended, today we are going to be starting with object-oriented programming. See, in the first 4 weeks, we have covered the basics of what it means to program. Like we have covered all the data types, the syntax, okay, the structure of programming, conditional statements, and all of that. And those are just tools which you can use to, make some programs, make software and all. But when you step in the real world programming case scenario, almost in 99% of the cases, unless you go for something like shell scripting or something like that, in 99% of the cases, you will be needing object oriented programming. That's because nothing as of now is, isolated in its environment. Everything is connected to everything else. And there are multiple levels of connection. Okay, like uh, take any example. Let's take the example of YouTube. Okay, there's an uploader, there's a watcher, there's the servers of YouTube, and there are so many different. There's the audio, video, like dislikes ratio, the comments, and everything is extremely interactive. So you cannot write code like this in just, in just one go. You need to divide each code in its elements, and that's where object-oriented programming comes in. You can divide your code into classes, into objects, into methods, and you can call all of these things whenever you need them, wherever you need them. Okay, so we are going to be starting with, okay, let me just use comments for now. Okay, we're going to be starting with classes and objects. Okay. So, first let's take a look at what a class is. Okay, so class is something that a user defines, and by user I mean the programmer. Okay, it's something a programmer can define, and then using a class you can make an object. Okay, so I have this image for you right here. Okay, so take a look at this. You have, let's say, the name of your class is a car. Okay, so a car can have many different attributes, right? A car can have, let's say, a car is built of many different components, such as, let's say, the body of the car, the headlights, the tires, the doors, the windows, the steering wheel, the engine, the exhaust pipe, and everything else. Okay, so these all are the components, or rather the attributes of a car. Similarly, in this case, the car has not defined by those attributes. The car has this car has been defined by the attributes of its color, its company, and its model, right? So let's try to program this. Just take a look at this picture, and now we will try to program this. Okay. What we are going to do is we are going to write class because we are making a class. So this is very easy, and then we will write car. Okay. We write this colon, and here we are going to be naming all three of those attributes. Okay, so let's just say color is equal to, and we have to give a default attribute. Okay, so color for default, let's say color is equal to white, and for company, let's say company is equal to, let's say, Ford, and for model is equal to, uh, well, let's take this example. Okay, model is equal to Mustang. Okay, so this is a class. Now what can we do is, let's say, if I run this, okay, as you can see, there's no output. That's because I haven't done anything with this class. Okay, so what I'm going to do is I'm going to create an object using this class. Okay, let's take, what should I name my object? Okay, I will name my object car1. Okay, so this is my first car is equal to car. Okay, I've created this object right here. So car1 is my variable, and the type of this variable is this entire class. Okay, so let's say I want to change the color of my car1. Okay, see, this is just a blueprint. This just defines how a normal car looks like, how a normal car, all the attributes of a normal car is. And this car1 is the exact car which I have. Okay. So let's say my car is not white, my car is red. So how can I access this attribute, the color attribute of car one? Okay, let's see how do we do that. What we are going to do is we are going to write car one dot color is equal to let's say red. Okay, and now we can just print car one dot color. Okay, let's run this and see what happens. You can see the output is red, right? So it's red because first I took my car one and then it changed its color from white to red. Okay, so accessing the attributes in a class is done through this dot functions. You see this dot right here. Car1 dot color means the color of my first car, and the color of my first car is red, and that's why when I print it, my output is red. And what happens if I print something else? Let's say I print car dot color. Okay, I'm printing the color of this class itself. And let's run this. You can see I'm getting the output as white because my default value of this attribute is white. Okay, so this is a very simple example of a car and of a class rather. And let me give you another example. Okay, it will give you more. It will give you better output. Okay, so we used car. Let's take a robot. Okay, see we have a class of a robot. Okay, so let's say you have a robot and let's give a name to the robot. Okay, name is equal to mm, let's say Siri. Okay, let's say the robot is made by Apple. Okay, so the name is Siri. The color of the robot is let's say again red, and we have the name and the color. Okay, if does anybody want to add any attribute to this? Let's think of one other thing. Okay, let's just think build. Okay, build is equal to let's just say metal. Okay, so we have these three attributes of the class of robot. And again, I'm going to be making an object from this class, and the name of my object will be robot1. Okay, robot1 is equal to robot. Okay, I'm going to do the same thing here. I want to change the name of robot1 to something else. Okay, what I'm going to do is robot1 dot name is equal to, and let's change it to Google. And let me print robot1 dot name. This is the exact same thing which we did for the car class. Okay, so we run this and we see that the robot dot name, which means that the name of the robot one has been changed to Google. Okay, so right by now we just saw the class and its attributes. What if I want to add some methods in my class? Okay, so we always, when if you go to the internet and you look at the examples of classes, they always have some methods. So let's write a method. Okay, we are going to be using the def keyword. Okay, I hope you will remember this from when we studied functions, right? And let's take the example. Let's say this is a robot and I want my robot to speak. Okay, what I'm going to do is I'm going to write def speak and I will write brackets. Okay, as you saw, as soon as I pressed the bracket key in my keyboard, this self keyword automatically came in my PyCharm. Okay, so this PyCharm is the PyCharm automatically wrote the self keyword. Not maybe any other IT will not write it, but I will tell you what this self keyword exactly is. Okay, before that, let's just define this function. Okay, so let me just return a string. Okay, let's just okay, first we will define a string. Okay, let's just take the variable abc. Abc is equal to a string which is hi, I am a robot. Okay, this is my string, and I want to return abc. Okay, so now what we are going to do is we are going to run this, we're going to try to run this method of this class. Okay, let's see if we can print this out from outside the class. Okay, so we already have robot1 is equal to robot. What we're going to do is we are going to be printing robot1 dot, okay, robot1 dot speak. Okay, so and I need to enter a bracket here. Okay, all right. Since the this is a function, okay, and function has bracket, and let's run this. Okay, and okay, I have this too. Okay, let me just remove this and I will run this again. Okay, and the output is hi, I am a robot. So as you saw this function, okay, I call this function of robot.speak, which means I'm asking the robot to say something. And what did the robot say? Hi, I am a robot. Okay, that's what's happening here. You must be thinking something, right? That I have this self inside of a bracket, right? Which means there is one argument that is being passed through, right? If you remember, for example, I will, uh, I will just enter this here. Okay, so this is not a part of the program. I'm just writing an example for you. As you remember, let's say def function or something. Okay, and here, if inside the bracket, if we have say 1, 2, 3, 4, and five arguments, okay, then you must remember that when we studied functions, if while defining the function, if we have, let's say in this example we have 5 arguments, right? So when we call the function, in that case also we must have 5 arguments. Okay, so what is happening here? Let me just remove this. What is happening here? Why is it that I do have one argument here of self, but I don't need to enter any value for that argument? Okay, for that what we are going to do is we are going to explain that we are going to be using a second robot. I'm going to be using robot2 is equal to robot. Okay, so I have 2 robots now. Okay, robot1 and robot2, and both of the robots are equal to this class of robot. Okay, I mean the values are all same because I haven't changed any of the value. All right, so I'm going to experiment with something. Okay, what I'm going to experiment with is I'm going to write hi, I am a robot named and then plus name. Okay. Okay, so it will. Okay, so it's throwing an error. Okay, it's out of scope. Okay, so let's just remove this for now. Okay, let's just let's just take it with hi, I'm a robot. Okay, so robot2 is also a robot and robot1 is also a robot. Okay, so what we're going to do is we are again going to print robot2 dot speak. All right, and let me print this. It says hi, I'm a robot and hi, I'm a robot twice. Why? Because we have 2 print statements here. So now we get to this functionality of the self keyword. Okay, so this self keyword means, okay, what does self actually mean? Self means the function itself, right? Like focus on the of the English meaning of the word self. So this self word is used to identify the object. Okay, so here we have speak, we have this function of speak. Okay, so when Python recognizes, okay, the speak function is being called, so it will go and look for the speak function. Okay, and it will find it in line 10, in the line number 10. Okay, then Python sees, okay, it has an attribute of self, which means first it has to look for the object. Okay, see the difference is that this function is inside the class, right? This function is inside of this class robot, but the function is being called in the object robot1. Okay, this is the difference. Okay, so focus on this. The function is in the class, but it is being called on the object. Okay, that's why to recognize the object, for Python to recognize that it is being called on an object named robot1, it is being called on an object named robot2 in this case. That's why it is using the self keyword. The self keyword means that it is recognizing itself. It is recognizing the object at which it, on which it is being called. All right. So this is how a class. This is so. This was the simple example of how a class and the function inside the not the function, rather a method inside of a class works, and how we can make objects from it, and how one object differs from the other. In this case, both are the same, but you can, let's just say, if we remove this, okay, and let's just see what happens if we return name. Okay, okay, name is out of scope too. Okay, I will look into it. Okay, and let's just keep it like this. Okay, so if you are looking for a definition, okay, I will just write something here. We'll just write this. Class is a user defined blueprint from which objects are created. Okay, so this is the definition of a class. And for object is a collection of data and methods. Okay, so these three are data. These three are three attributes which signify data, and this is a method. Right. So this object, the object of robot one, has both data and methods. And in the definition, you can see that, it is a collection of data and methods. Right. So these two were the simple example, but the class and method are quite big concepts in of itself. Not, I would not say the concepts are huge. It's just that the implementation of the concepts are huge. So every small detail which you will come across while programming, every small detail is important in one case or the other. Okay. Anybody has any questions up to this point?
सर मुझे थोड़ा समझ नहीं आया स्टार्टिंग से.
Okay. In the starting, okay. So, okay. We have a class of a robot. Okay. So again, we will go to this image of a class. Okay. A class is like a blueprint. Okay. Rather than a blueprint, take let's take a simpler example. Okay. What's something that can be divided into a component? Okay. You all must know a mobile phone. Okay. Let's take the example of a mobile phone. Okay. When you go and buy a mobile phone, you look at its different components, right? A mobile phone has a processor, a RAM, a display, a speaker, a headphone jack, cameras, multiple cameras now, okay, buttons, and the build quality, right? The connectivity. All of these are different components of a mobile phone, right? So, and you can also say that all of these components come together and build what we call a mobile. So, let's just write this, okay? So if we take class smartphone, let's take a smartphone, okay? I define a class of smartphone, and okay, so try to understand this, that how it like try to understand what I mean by a class divided in its components. Okay, just in my as in the example, a smartphone was built of these different things, right? The RAM, the processor, the memory management, the display, the speakers, and all of that. Similarly, a class is also made by all of these different things. Okay, so a class is made. I have a class of smartphone. Okay, so I am going to speak. I'm going to start writing my components. Okay, my first component is display. Okay, display is equal to, let's say, AMOLED. AMOLED. Okay, and then I can write something else. Okay, it's showing me an error. Okay, let me just remove this. Okay, the error is gone. All right. So the display is equal to AMOLED. Okay, and the processor is equal to, let's say, Snapdragon. What's a recent one? 888, right? Snapdragon 888 is okay. And what else? Okay, let's say the speakers is equal to, let's say, dual speaker. Okay, it has speaker both on the top and the bottom. Okay, so now I'm okay. So this is my class of a smartphone. Okay, and it has these different features, these different components. Okay, now I'm going to be making a smartphone. Okay, and which smartphone do you guys like? Okay, so I think OnePlus is quite famous. Okay, I also have a OnePlus phone. Okay, what I'm going to do is I'm going to write OnePlus. What's the upcoming OnePlus phone? Okay, let's just take OnePlus 9 Pro is equal to, okay, OnePlus 9 Pro is a smartphone, right? So OnePlus 9 Pro is equal to okay, is equal to smartphone. Okay, so I think this example is a little better, right? OnePlus 9 Pro, you all know that is a smartphone. So I declared it as a smartphone. OnePlus 9 Pro is an object, and the object belongs to a class of smartphone, right? This example works even without programming. Okay, this sentence which I just said, that OnePlus 9 Pro object belongs to the class of smartphone. This sentence is applicable even in the real world, okay, outside of programming. Now I can change this. Okay, let's just take, okay, this is quite long. Okay, let me just remove this progress. Just keep with OnePlus 9. OnePlus 9 dot speakers. Okay, let's just say I don't want two speakers on my OnePlus 9 phone, and I only want one speaker. Okay, speakers is equal to, and I'm going to write mono. Okay, so let me just, and then I'm going to print. I'm just going to print one plus 9 dot speakers. Let me run this. And as you can see, the output is mono. So I hope it's clearer now. Okay, a class is built of its components, and then you can use those components to build something. Okay, in this case, I had the components of an average, expensive smartphone here, and then I use that smartphone components to make something, to make an object, OnePlus 9. And then I can, customize it. If I don't want an AMOLED, let's say I want an IPS display, so I can change this. I don't want 888, let's say I want 725G. In that case, I can, change the processor and all of that. Okay, is it clear? Okay, let me just comment all of this out. Okay, and moving forward. mm, okay, so now we move on to encapsulation. Okay, and let's go back to this car. Okay, and don't focus on the
Excuse me, sir.
bottom. Yes,
Like you said, uh, like you said, one plus
yes,
nine, one plus
yes.
nine equal to, and the car one equal to car. Is that where you are calling the? What is the name of that statement?
Okay, I didn't get your last statement. Can you please repeat?
One plus one plus nine equal to smartphone with function with method. Car one equal to car with method. Uh, what is the name of the statement?
Okay, I mean, it is built of metal or plastic. Yeah, you're saying that.
Now, what I'm saying, take for example,
Okay,
one plus.
I mean, I
You
didn't
said one plus
add it.
one. Excuse me, now.
Yes.
One
Okay.
plus nine equal to smartphone function. Car one equal to car with function. I'm asking you, what is the name of the statement? What is the name of that statement?
Okay,
One line
the name
number.
of this statement.
Yeah.
Okay, so this is, we won't call this a function. Okay, so we are just creating an object from a class. The name
Okay.
of this statement is object creation.
Okay.
Okay, so let's just go ahead. Now we are going to get into encapsulation. Okay, So for that, let's go back to uh, this image of a car, okay? And forget this bottom half of this image, okay? We are done with that. Just look at this. Just look at the this image of a car, okay? So if you have ever noticed or if you have ever thought about it, a car is a very complicated machine, right? Like, how does an engine actually work? What is torque? What is the mathematics of a torque? How does movement of an engine, play with the RPM, rotations per minute of a tire? Okay, what is the aerodynamics? There are thousands of different things which are used to make a car. But when you drive a car, you don't need to know all of that. When you're driving a car, you don't need to know what is the thermodynamic property of the coolant which you have used inside the car. You don't need to know the refractive index of the glass in front of the headlights of the car, right? So there are thousands of things which are used to make a car. Okay, for example, like even when you open the door of a car, right? When you take the handle, then you pull the handle, okay? Even the degree, the angle at which the handle will move and then it will open the door, even that is calculated ergonomically. Okay, there are all these minute calculations which are they are mind-boggling if you ever look into it. And all of those things, make up a car. But you don't need to know all of that, right? You don't need to know how, like, you don't need to know how an engine works, right? Like, you don't need to know when an engine heats up. Okay, sometimes you need, like, there are some things which you need to know, okay, such as how does a steering work. But as I said, you don't need to know, as I said, the refractive index of your headlights and everything. So similarly, this is a perfect case of encapsulation. Okay, so what's happening here is there are thousands of things in a car, and those have been minimized to, let's say, a few tens of, or maybe at the maximum, if you're a really good driver, at best, maybe a few hundred. Okay, from thousands, it has been minimized to 100. So what do you need to know? You need to know how a steering works. You need to know how the accelerator, the brakes, the wipers, the indicators, okay, and the warning labels when you start a car, okay, and the brakes and everything. You only need to know these things to understand how to drive a car, right? So the philosophy behind this, okay, just taking thousands of different things and minimizing it to just a few things to be able to implement it, it's called encapsulation. Okay, so and let me show you another image. Okay, so you guys all know that this is just a normal capsule. Okay, the reason I'm showing you this is because, so I'm sure most of you, after this lecture, I hope most of you, okay, you go back and study all of this yourselves too, right? Like, I want you to go and study what encapsulation is, what abstraction is, what polymer. We will also get to that in this class and tomorrow's class, but I also want you to study this. So I have noticed, okay, what happened with me and what happened with my classmates is that the reason object oriented is said to be difficult is not because it's complicated or it's difficult to implement. It's nothing like that. It's because the entry point is a little higher. Okay, what I mean by entry point being higher is that when you are, let's say, you are starting to study one of the concept of object oriented, okay? Let's say you are studying, for example, you are studying encapsulation, okay? When you start to study encapsulation, you will be confused, okay? Like, I can guarantee you, at some point or other, if you think that you are able to understand every line as you're going through it, then you are not understanding it in the right way. Most of the people will get confused while trying to read while trying to study this for the first time. And the reason for that is, let's see, again, we will go back to the example. Let's say you're studying encapsulation. You will understand it completely after you have already completed studying it. Okay, let's say the description. Okay, let's just, for example, I mean, it doesn't work like this. I mean, there's practice and writing and all of that, but for the sake of example, let's say there are 100 lines. Okay, there is 100 lines of explanation of what encapsulation is. Okay, so when you start reading it, when you're on line one, maybe you will think you are able to understand it. When you are on line number, let's say you are on line number 25, you will be confused. Okay, you won't be getting what is happening. And if you are able to understand what is happening, you will be confused at why we are doing this, why we are doing this, why we are doing that, what is all this. Okay, what is private, what is protected, what are all these keywords, what is access modifier. Okay, so when you're reading this, okay, but when you have completed it, okay, when you have completed studying encapsulation, and then when you go back and read it again, that's when you will be able to understand everything. So the problem which happens most often is that when you're reading it for the first time, okay, at let's say you have been reading it at around, let's say you are at line number 50, okay, and you are confused, you don't know what's happening, and if you do know what's happening, you don't know why it's happening. So in that case, what students do is that they start reading it over again. They think they missed something and they start reading it over again, and then the same thing happens, right? You have to read all of it and then go back and then you will understand it. But the problem that happens is that when some students, what they do is, if they are not able to understand it, they go back and read it again and they get confused. The number of problem is that after a point you will feel lost. You will feel lost. You won't know that where do I start, where do I end, what do I do. When you start reading it from the beginning, you will feel like I already know this. But when you start implementing it, you will feel like I don't know anything. So this zone of I already know this and I don't know anything how to implement it. This zone is called being lost. So I think, okay, so I have tried to come up with a way which will, at the least, it will prevent you from being lost. So, so for that, what we are going to do is we are going to build a point of reference, and this point of reference we are going to be building outside of programming. Okay, so now take a look at this picture. Okay, this is a picture of a capsule, right? I think almost all of you must have taken a capsule at one time or the other. As kids we get sick a lot, and when we get sick we go to the doctor. The doctor prescribes us medicine, and some of the medicines are in the form of a capsule, right? So here you can see there are two different components of this capsule, right? There is a plastic cover. I mean, I don't know what it's made of exactly, so I'm just assuming that it's some sort of plastic or some biodegradable plastic. Okay, so there's this plastic, and inside this plastic a there is medicines, right? This red and white dots which you see. These are medicine. Okay, I mean this substance has the medicinal properties. So this is an open capsule, right? Someone has opened the capsule and the medicine is falling down. So so imagine if I close this capsule, right? If I close this, what will happen is that this plastic cover will come on the top, and inside the plastic cover will be the medicine, right? You can imagine that, inside the cover is the little dots, which is the medicine. So understand the semantic of this and in the word encapsulation, which it means in English. Okay, and I mean in the normal use of the word encapsulation. So what's happening is this plastic cover, okay, this red and white plastic cover is encapsulating the medicine. Okay, that's why we call it a capsule. Why? The plastic cover is storing medicine inside of it, right? It's encapsulating medicine. That's why we call it a capsule. Okay, for that I'm going to open Chrome and I'm going to write encapsulation definition. Okay, now a very fun thing is going to happen. Okay, so what you see, when I write encapsulation definition, I get the definition which is in programming. Why? That's because this word is much more used by programmers than by normal people. So what we're going to do is I'm just going to write encapsulation English definition. Okay, and here we have this. Let me just zoom in. Encapsulation, the action of enclosing something in or as if in a capsule, right? So again, let's go back to this image. This plastic cover is enclosing the medicine, right? And it is enclosing it inside of it, which means it is encapsulating it. And that's what the definition here says too, right? So now you have a point of reference of what encapsulation means in general. So now we can get into programming, okay? So yesterday, Parvez and I were discussing, okay, like how do we go about, okay, we have tried, we have been experimenting with different things. We have tried PowerPoint presentation and we have also tried the PDF. So this time what we're going to do is we are going to be, you know, we're going to be looking for resources. Okay, I mean, I have already prepared my definitions as an example for all of that, but just to show you, I'm going to be searching for the topics in front of you so that you also know what how to, like, which sites to refer to, which keywords you have to use while googling, right? So in this example, right, to get the real definition of encapsulation, I had to add this word English, only then I got it. Okay, so what I'm going to write is encapsulation Python. Okay, and there I have Geeks for Geeks, I have Facebook programmers. Okay, let's take this for example. Okay, Geeks for Geeks, we will take the next time. All right. So, okay, this is the entire object-oriented page. Okay. So let's search for encaps. Okay, here we have it. All right. So what it's telling us, okay? Let's see its definition of this website. Okay, so its website is we can restrict access to methods and variables. Okay, this is what the definition of this website is. Now take this as a reference point to the car example, right? We, when you buy a car or when you're driving a car, the car manufacturer isn't giving you the access to tinker with the function of the engine, right? So your access to the insights of an engine is restricted. Similarly, while using encapsulation, your access to the functions inside, to the methods inside of a class can be restricted. Your access to the variables inside of a class can be restricted, okay? This is the way encapsulation has been defined here, okay? So now we will go back to our IDE. Okay, and what we're going to do is, okay, so what let's I'm okay, let me think, what have they done here. Okay, so as you saw, we have to restrict the access. Okay, and to restrict the access we have three tools with us. Okay, let me just do this. Okay, we have three tools. Okay, and the name of the tools are access modifier. Okay, try to understand what this means. We are modifying the access which we are giving to other programmers, right? Let's say you're working in a company, you write a Python program. Okay, you write a file, and then you're giving that file to someone else to add something to it, but you don't want that, not to add something to it, but to use that file to build something else. Okay, but you don't want that person to be able to access everything in that file. In that case, what you will do, you will modify. You will modify the ability to access things inside of the file which you have written. That's why we call it access modifier. Okay, so there are three types of access modifier, which is public. Okay, public, I believe all of you know this. Okay, the public means if something is public, then everybody will be able to access it. Okay, there's public, there's private, okay, and there's protected. Public means that everybody will be able to access it. Private means that nobody will be able to access it except for within the class. That variable can be accessed within the class, and I will show you in an example how. And then protected means that that the class can access it, and the Other classes derived from those classes can access it. Okay, but outside of that, even protected cannot be accessed. Okay, so now let's take an example. Okay, so we have three. We have already used three. We have used a robot, a car, and a smartphone. Okay, if you have any preference for an example, okay, if you click better with an example, I will continue with that, or you can tell me. I will just take a look at the chat box. Okay, no, we have not prepared a presentation because uh, okay, Parvez has linked something. Yes, access modifier is a subtopic of encapsulation. Okay, among these three examples which you took, okay, if you can just unmute yourself and say which you want to continue with in case you click better with another. You know, continuity is important in this.
It's well understood, sir.
Okay, which one?
It's well understood. You can go ahead.
Okay, so I will just continue. Okay, so let's get back to, let's just take robot. Okay, we had a method here too. And I will have to remove all this. This works, right? Okay. So I have this class of a robot here. Okay. So what I'm going to do is I'm going to show you so these three variables, these are, these three variables are public. Okay. Why? Because I haven't modified their access yet. And by default, each variable is public inside of a class. So what I'm going to do is I'm going to, make another class. Okay, I'm going to make another class of, let's say, machines. All right, and I'm going to make a class of machines, and inside of this class, I'm going to make an object. Okay, I'm going to make an object of, let's say, what is my favorite machine. Okay, I will use the variable fav. This means I am making an object of my favorite machine. Okay, and my favorite machine is, let's say, a robot. Okay? And I want to access this favorite. Okay, I want to change the color of my favorite robot. Okay, how do I write this? How do I write a line so that I can change the color of my favorite robot? Okay, any ideas? Okay, anybody, any ideas that how do I access the color of the robot of my favorite machine inside of the class machine? Okay, nobody. Okay, so what I'm going to do is first let me create an object of machines. Okay, let's just take an variable xyz is equal to machines. Right? I have this xyz is equal to machines, and what I'm going to do is I'm going to write fa. I'm going to write xyz. Okay, so this is my object. Inside of that object, I want to access this fav. Okay, my okay, so an object can come inside of an object, right? If anybody has studied JavaScript, you must be familiar with this concept, okay, of objects inside objects. So xyz dot fav dot color, okay, is equal to blue. Okay? So pay attention to this line. XYZ is my object of a machine, okay? XYZ is a machine. And inside of machines, I have my favorite machine, which is a robot. Okay, so XYZ dot favorite machine which means favorite machine inside of the class of machines, and then I'm accessing the color. Okay, I'm accessing the color of my favorite machine inside of my class of machines. Okay, that's why I'm using two dots here. You will be seeing two dots when if you are building projects in, let's say, machine learning. If you're using TensorFlow, you will be seeing lots of, I mean, TensorFlow dot keras dot model dot train. Okay, these are three dots here. Okay, you will be seeing a lot of things like that. In that case, now you will be able to understand why there are two dots or why there are multiple dots. That's because they have built a class and they built a second class, and using the second class they're making an object of the first class. Okay, that's why there are multiple dot functions in TensorFlow and Keras and all of those huge libraries. Okay, so we have this. And now what do we get to? We get to access modifiers. Okay, let me just remove all of this. Okay, we have it out. Okay, I'm not audible. Okay, am I audible now? Okay, did anybody, so was it an error on my side, or was everybody else able to hear me?
Yeah, you are audible.
You're
Yes, you
audible,
are
maybe
audible.
from his own side.
Okay, so Nikhil, you can tell me what part you missed, and I will quickly go over that again. Okay, Nikhil is not responding. Anyway, so now we get to access modifiers. Okay, I mean, we get to the implementation of access modifier. You guys already know what public access is. Okay, congratulations. That this by default, it is public. So what I'm going to do is, I'm going to write something. Okay, I'm going to, do I have an extra space here? Field 1, 2, 3, 4, 5. Okay, right. That's the error. Problem here. Better. Now we have four spaces. All right. So what I'm going to do is I'm going to build an object. Okay. Let's just build the same object as before. Robot1 is equal to robot. Now I will try to change the name of the robot. Okay. And for that, what I have to do is robot1 dot name is equal to, let's say I will change the name to Alexa. And I run this and it runs, there's no error. And what I'm going to do is robot1. Now I'm going to print. Okay, I'm going to print robot1 dot name. When I run this, I get the output as Alexa. And the same thing I'm going to do with the color. Okay, so what color is Alexa? Can anybody tell me? To buy an Alexa on Amazon, what color does it come as? So if
White or black?
yes, so if I remember the advertisement correctly, it's you can buy it in white, but it's mostly black, and the top portion is a little blue. Okay, so let's just go with black. Okay, so, and I'm going to print this too. Okay, I'm going to print robot1 dot color. Okay, I'm going to run this, and I get Alexa and the color black. Okay, great. Now what I'm going to do is, let's say I work at Amazon. Okay, and I work at Amazon. I'm making Alexa, and I want a user to be able to change the name of Alexa. Okay, how does an Alexa work? So if I have an Alexa in my room, okay, I have the the speaker. If I say, hey Alexa, it will start listening to me. What if I want to change the name? Okay, if I want to call it something else instead of Alexa, maybe if I work at Amazon, maybe I want to allow the users to be able to change the name. Okay, but what if I ask Alexa, okay Alexa, what is your color? In that case, Alexa will say, okay, that my body is built of black color. Okay, but I don't want the user to be able to change this. Okay, because if Alexa is made of the black color or the white or blue color, okay, like the color is permanent, right? So I don't want a user to be able to change what Alexa says when asked about its, build, the build quality or the build color. But I want the user to be able to change the name of Alexa. Okay, I want the user to be able to change what they want to call Alexa. In that case, what I will do is I will leave the name in the public scope, okay, in the public access modifier, and I will change the color to red. Okay, I will no no, I will change the color to private. I'm sorry, not red to private. Okay, and here I will change red to, let's say, white. Okay, just for the sake of it, white. Okay, so this double underscore. Okay, I have entered underscore twice, which means that this variable color is now private. Okay, nobody can access it. So try to run this. Okay, did, okay, this should not have happened. Okay, did I make an error? All right, this is private. Okay, Parvez, can you help me out here? So I ran this before the class and this worked. Okay, so now we have encountered an error. Okay, this is probably a syntax error. Okay, maybe probably a a small keyword or a small thing which I have skipped. So what we're going to do is we're going to get back to what we googled, and we are going to see how we sort out this error. Okay, so here we have private attributes underscore, a single underscore, or a double underscore. Okay, let's see how they have done it. Hmm. Okay, got it, got it. So what's happening here is when I write robot one dot color, it is making a new attribute. Okay, so when we added the two underscore for that color, okay, when we added this two underscore, the name of the variable was changed, right? Earlier, the name of the variable was color, and now the name of the variable has been changed to underscore underscore color. So when I run this line, okay, when I run robot one dot color is equal to black, it is making a new attribute, and then it is changing the, and then it is applying the, then it is, and then in this line, it is printing that attribute. Okay, so what happens if I write here? Okay, what if I want to change this thing exactly? Okay, try to run this, and here also I will write underscore underscore color. Okay, try to run this, and it still ran. Okay, this should not have happened. Okay, so which means that my debugging was incorrect. And let's see how this works. Okay, here we don't have much data. So now we're going to go on Geeks for Geeks. Okay, I said that, as I said, next time we will go there. So we will go to Geeks for Geeks, and let's take a look at how they have implemented the private keyword. Okay, here we have private members. All right. Okay, so let's try doing this with a base class. Okay, and let's run this with a base class. Okay, I'm going to write another class, and in the class I'm going to let's just take the example of last time, class machine. Okay, inside machine I'm going to make an object xyz is equal to a robot. Okay, I'm going to try to change it xyz dot underscore underscore color is equal to, let's say, red. Okay, and let me just remove all of this. And will this work? Okay, and this will also work. So is it just a single? Parvez, are you there?
Yep.
Can you get me the data on, okay, when is the access restricted in of a private member? Okay, can you get me the syntax? Okay, I tested this out. Okay, I mean, I've read it and I tested this out too, but I think I'm making a syntax error here, and I don't want to waste their time.
Okay, okay. Let me see.
Okay, so it's 12:05. Okay, and around 12 o'clock we always take a break. Okay, so if you want to ask some questions, you can ask that, and in the meantime, I will figure out what the problem I'm facing. All right.
Okay, sir.
Okay, guys, so here's the error, here's the mistake I was doing. Okay, so mistake I was doing is that although this variable, the underscore underscore color, is private, private means that I cannot access it, which means I cannot print it, but I can change it and then I can print it. Okay, so let's by that what I mean is, in this line, okay, in line number 59, what I'm doing is I'm writing robot1 dot underscore underscore color is equal to black, which means first I'm changing the color, okay, and I have changed the color outside of that class, right? I've changed the, okay, so my class ends here, okay, this is the last line of the class, and I'm changing the color here, which means I'm changing it outside of the class. That's why I'm able to access it, right? So I run this, and this runs perfectly. The access modifier will arise when I do not print this. Okay, I comment this out, which means I'm not changing the color. Okay, and then when I run this, I get an error. Okay, the error is that robot has no attribute color. Okay, this error is telling me that this class robot has no variable, has no attribute, has no component named underscore underscore color. Although it does, but it's telling me that there's no variable by this name. And the reason for that is, the reason for it's telling me that is because this underscore underscore makes it private, makes it such that when you make a variable private, there's only two things you can do. Either you can access it inside of that class, or you have to change it. You have to either change it once, and when you have changed it, then you will be able to access it. Okay, I will stop sharing just for a second, okay, and then I will show you one example, okay, of something which I have written. All right, so take a look here, okay? Take a look at this Python file, okay? So what's happening here? Okay, so the reason I stopped sharing my screen is because my API ID was here, my API key was here, and I had to remove it. Okay, so just a bonus point for you all, that if you ever are working if you're working through a service, you will get an API key. Never share that API key with anyone. Okay, that's the reason I stopped sharing. And first I removed the API key, and then I started sharing, because if any of you saw my API key, okay, then you will be able to access that service through my account. And when you do that, if you keep using it, you can you can even cost me some money. Not just me. If you get anyone's API ID, you can do that. So I removed the API key, and I wanted to take a look at this Python file. Okay, I have imported a lots of stuff. You don't need to pay attention to that. Pay attention to here, okay, to this part. I have this function, okay. I have my function on render here. You don't need to focus on what this function is doing, okay. Like don't pay attention to that. Just pay attention to that. I have this function here, okay. Let me just minimize all of this, okay. I have quite a few functions here, okay. I have my on render second win, first win, third win, on render 3, fourth win. Okay, I have written many functions in this class, okay. Like it's around, okay, it's over 360 lines long. But if you have noticed, I have written all of these functions, but I have not called any of this function, right? And in this entire Python file, I have not called any function, right? So why have I even written all of this if I haven't called any of it? Okay. So the reason I have written this is, okay, take a look at the name of this file. Okay, the name of this file is subcard.py. And now we go here. Okay, this is my main file. Okay, this is my main file, and take a look at line number 6. What the line number 6 is: from subcard import star. What this line is doing it, okay, from subcard import star. Star means everything. Okay, here also we have star, and we have here, okay. So there are three libraries, three packages which we are importing everything from. So this means what Python understands from this is that first it will look for a Python file named subcard. Okay, it looks for this, and Python finds this file here. Okay, this is my subcard file, and inside of this subcard file, it will import every function from this. Okay, when I write from subcard import star, which means import everything, all of these functions are now accessible in that file, in this file. Okay, so this is how you can work through multiple files. Okay, like many times you will not be only working in one Python file, you will be working through multiple of them, and that's how you will be able to, import or export functions through one file or the other. When you work in a framework such as Django or Flask, you need to be able to know this. Okay, so this is what's happening. So the reason I'm telling you this is here in this, okay, I have this file here. Okay, so inside this file, okay, let's say I'm working in an organization. Okay, somebody told me to write a function. Okay, let's go here. Okay, somebody told me to write a function to render a GIF. Okay, this function is basically to render a GIF. Okay, I have my group of images and I'm combining those images to make a GIF. Okay, that's what this function is. But don't get to the syntax, it's a little complicated and I'm using some tools. Okay, so somebody, let's say my boss tells me, okay, Siddharth, make a function which will be able to render a GIF on our interface. Okay, so I write this function and then I give this file to my boss. Okay, and then my boss gives my function to somebody else. Okay, to somebody, let's say to a freelancer. Okay, so what in that case, what's important to do is, let's say in this function, all of my data is public. Okay, it is public because I am on both ends, right? I am the one who's writing the function and I'm the one who's calling the function. So that's the reason I am making everything public. But if I am writing all of these functions and then I'm sending this file to somebody else, let's say I'm sending this file to Parvez. Okay, and I don't want Parvez to be able to access some of these things. Okay, I don't want Parvez to be able to change some of these things. Okay, let's say I have my delta draw time variable. Okay, I have this variable delta draw time. I want this variable to stay here because I'm using this variable to calculate. Okay, I'm using this calculate to calculate how long a frame stays, but I don't want somebody else to be able to change, to be able to get the exact value which I'm using for myself. In that case, I will just enter two underscores here. Okay, so this is the practical implementation of public and private data access modifier. So if I write this here, if I write double underscore here, and if in my main file, if anywhere in my main file, okay, I don't remember which function is called where, I wrote this long ago. If in my main file I'm trying to access the data, access the value of this, I won't be able to do this. Why? Because it is private. Okay, so let's see if we can get some other analogy from this. So I have quite a few functions in this too. All right. So yeah, does anybody have any questions on why we use public and private access modifier? Because I can understand that it can be a little confusing because up till this point, only you have been writing code for yourself. And when you write code for yourself, it doesn't make sense to make anything private, right? You have access on every end. Like you must be thinking that what is even the use of making something private, even if I can just go and edit the value on my own. Okay, any questions? Okay, so no questions. All right, so all right, that's it for I think access modifier. Okay, we missed something which is protected, right? So we have three things: public, accessible to all; private, accessible to no one outside of the class, but it can be changed and then it can be accessed. And then we have protected. Protected is something which comes between public and private. So what happens in protected is that you can access protected inside of the class. You can also access protected inside of a class inside. Okay, so this is called a base class. Okay, base class means that, okay, I mean, for example, this variable is inside of the class. Okay, so the robot is the base class. What if I put this class robot inside of another class? In that case, a robot will be a derived class, right? It will not be a base class anymore. It will be a derived class. So so the difference between public and protected is that in protected, I can access variables inside of the class and inside of the classes made using those classes, which are called derived classes. Okay, let me just write this definition here. Okay, accessible in base class and derived classes. Okay? This is what we mean by protected. Okay, so we have already seen the example for public and an example for private. Okay, private, I knew there was some error in private, so I will just rerun this. Okay, rerun this. So as you can see, I try to print robot one. I try to print the color of the robot, but since the color is private, it's telling me that, there's Python is telling me that it doesn't even exist. Okay, that's the thing. All right. So I will not be showing you an example of protected. Why? Because the extent to which we have studied class and methods and objects right now, you won't be able to, I won't be able to show you the difference between public and protected. Okay, I can show you. Okay, if I just remove one of the underscore here, now this variable is protected. Okay, so I will now this variable is protected. I run this and it prints. Okay, but I won't be able to explain to you what's the difference between protected and public unless we study encapsulation. Not encapsulation, inheritance. Okay, and inheritance is a huge topic in of itself, so that we are going to be doing tomorrow. So tomorrow we will do inheritance, and then we will come back to access modifier and we will study protected. Okay, we will study where protected is accessible and where it is not. Okay, so for the final topic of today, we are going to study abstraction. Okay, I'm going to just need to comment all of this out. Okay, and now we are going to study abstraction. Okay, so again we will go to let's say we'll go to a Google Chrome and we will write abstraction in Python. Okay, abstraction in Python. Right, so let's go to Java T point. Okay, this time let's see what they have to tell us. Abstraction is used to hide the internal functionality of a function from the user. User can only interact with the basic implementation of the function, but the functioning is hidden by them. Okay, so let's see if they have given any example here. Okay, great, got it. So abstraction is more of a theoretical concept. Okay, so let us go back to this file. Okay, this file. Okay, if you think this code is a little complicated, that's because it's not written in a linear way. That's why it might look complicated, but Bear with me, okay? And okay, this fbgui.py is my main file, okay? And all right, let's take this example, okay? I have my file, okay? I have this function here, okay? Second wind, okay? You can see this, right? So I'm saying that if number of images is equal to 2, in that case, I will be calling my function of second wind, okay? I'm a second wind, and inside the second wind, I'm setting three attributes. The attributes are the first image, image at index 0, image at index 1, and the description of those images. Okay. So this is, I'm calling the function. Okay. But this function, second image, this does not exist in this Python file. Right. If you look through all of this, in this Python file, this function does not exist. Why? Because this function exists in the other Python file, which is this one, right? Here is my second win function. The second win function is asking for three attributes, which are image1, image2, and description. And what are we giving it? The first image, image at index 0, the image at index 1, and the description. Okay, so we are calling the function correctly, and this function is doing quite a lot of things. Okay, like it's a GUI based function, so don't don't try to decode it, because if you try to decode it, first you need to know which GUI I'm using and the attributes of that interface. Okay, so the point is, let's say I write this function. Okay, let's say I write this function. Okay, I write this function, and then I tell Parvez, okay, okay, Parvez, I have written the function, okay, and in the name of this function is second wind, and the function is taking three arguments. Two of those have to be images, and the third has to be a text. The third has to be description. Okay, a description is in the form of a text. Okay, this okay. So imagine I'm talking to Parvez on a phone call. Okay, that's what I tell him. Okay, the name of the function is this. The function is taking three arguments, and I tell him what the function is doing. Okay, I tell him that the function is returning this, the function is returning that. When I tell Parvez these three things, okay, the name of this function, the attributes of this function, and the output of that function, just using these three tools. Okay, I will write this here. Okay, the name, not here, the name of the function. Okay, the name of the function, the attributes of the function, and what else? The output of the function. Okay, just using these three things, Parvez or anybody else will be able to use the function which I have written, where they will be able to use the function which I have written in their program. Okay, so if I write, okay, they, like Parvez, will have no need to study how I have implemented the function, what code I have written, how I've done it, why I have done it. He doesn't need to know anything of that. He just needs to know these three key topics. And once he knows these three things, he will be able to implement it in his own program. This is called abstraction. Okay, now let's go back to Java T point. This is what they mean by abstraction. It means abstraction is used to hide the internal functionality. Okay, right. I'm hiding all of, okay, by hiding I mean that Parvez doesn't need to see all of this. Parvez doesn't need to see. If okay, if I can also hide it. If I, in case I use an API, I can completely hide it, but we will get to API towards the end of this programming classes. How to access APIs and build great projects. Like API projects are the best. Okay, so Parvez doesn't need to know any of this. Even if I hide everything, Parvez will still be able to use it to its full extent. Why? Because he knows these three key points. Okay, this is what we mean by abstraction. Okay, does everybody get the concept of abstraction, the theory? If you have any questions, you can ask me. Okay, so nobody. Okay, yes.
Excuse me, sir.
Yes.
When you say abstraction is the technique to hide the basic functionalities, can we say
Yes.
something like ATM? Is it an example? ATM?
ATM, yes, ATM can be an example. But
Okay.
the difference is ATM is like when you go to an ATM, you are a user, right? You're using the ATM. You're not a developer. When we use the concept of abstraction, it is mainly used for from developer to developer, from programmer to programmer. In
Okay.
ATM, sure, things are hidden. Okay, you cannot see the functionality inside of the ATM. But same is the case for anything else, right? When you're using a mobile phone, you don't know what's happening inside of a mobile phone. When you're using a laptop, you don't know there. So for the user, okay, for the user, everything is hidden. The point is what is hidden for the programmer. Okay, if something is hidden for the programmer, that's when the key concept of abstraction is used. Okay, let's say I work in a bank. Okay, and inside the bank, let's say I work in a bank and I am a programmer there. Okay, the bank manager tells me to write an algorithm to sort out money inside of that ATM. Okay, and but so I have been given access to write program for the ATM, to sort money, to pick which note and that, but I will not be given access to the part of the code of how the ATM itself is working. In that case, abstraction is applied. Okay.
Yeah, I got you.
Okay, so we have been doing we have been consistently doing something, which is whenever we study a topic, first we try to understand the semantic of it in normal language, and then we see how that a word translates into the domain of programming, right? We did this for function, we did this for encapsulation, and let's do the same thing for abstraction. Okay, abstraction. Okay, let's take a look at abstraction definition. Okay, I'm going to zoom in a little. Quality of dealing with ideas rather than events. Okay, the freedom for representational qualities in art. So, have you guys ever seen abstract art? Okay, rather, I will show you. Okay, I really like abstract art. I will. Let's see if we find something which I like. Okay, yeah, this one. Okay, take a look at this. Okay, when you first take a look at this, you will see, okay, some idiot just used two paintbrush and multiple colors, and he just threw paints at a piece of paper. Okay, right? So this is an abstract painting, and abstract painting is different from a normal. Like when you paint, let's say paint mountains and a sunset and a river. In that case, you are printing something specific. Okay, we know what it is. But as you saw in the definition of abstraction, okay, let's go back there again. Okay, the abstraction means the quality of dealing with ideas rather than events. Okay, rather than painting the event of a sunset, you will be dealing with the idea of a sunset. In that case, you will be painting an abstract art. Freedom for representation of qualities in art. Okay, so with what kind of freedom are we talking about? When you're painting a sun, okay, you will always be painting sun in a circular way, right? A sun is circular in shape when we say it. But what if, let's say you see the sun, it's circular, but you don't want to paint it in a circular way. Okay, you want to paint it, like let's say you want to paint it in a square way. Why? Maybe because you feel the sun is a square. Okay, I know it sounds idiotic, but try to understand the concept of freedom for representational quality, which means that if you feel something which is different from how it looks, and then you can express it in the way you feel, that's the freedom it is talking about here. Okay, in abstract art. And take a look at, I have studied this painting a little. Okay, and I forgot the name of that artist, but this is supposed to represent anxiety. Okay, let's say you have a big job interview, okay, and you are really scared, or you have to go on stage and give a speak and you are very nervous or something. Okay, or maybe something bad has happened, okay, and you are feeling very nervous, your heartbeat is high, and your mind is completely disorganized, you cannot think straight, right? This painting is supposed to represent that. Okay, and I'm guessing to some of you, okay, to at least I'm is making a rough estimate to I think 20-25% of you now it would have clicked, right? Before this was just a random paints thrown on a piece of paper, but when I say that it is supposed to represent anxiety, it is supposed to represent nervousness. Now it makes a little more sense, right? Like when you're nervous, your brain is completely fried. This is supposed to represent fried brain. This is what abstraction, this is what abstract art actually means in real life. And now you can understand what it means in programming, right? I can write whatever code I want in my function, okay, in any way I want. You don't need to deal with what in what way I have written. You don't need to understand where I have thrown the paint on the paper. All you need to understand is what I'm trying to represent using that function, using that abstraction. Okay. So yeah, these all were the topics of today. And yep, thank you all for coming. And tomorrow will be studying the other topics of we're going to study other topics of object oriented, which is not encapsulation, inheritance, polymorphism, and we'll come back to the protective access modifier. Yep, there is a need for review. Yep, I mean, this is difficult. Okay, I do not expect anyone to understand everything in their first try. Like object oriented is difficult. So I will help you and you also help me. All right, let's go study, ask good questions. Okay, I will be happy to help, but put in an effort from your side. Okay, I've given you reference points and I've given you how to look for the reference. Okay, if you are confusion point, I've already shown you what to Google and which sites to refer to while studying to them. You can also use YouTube. Okay, if you are a better visual learner, in that case, very good. You can use YouTube also. Okay, implementation of three. You're talking about the private, public, private, and protected, right, Paul?
Yeah, sir.
Okay, so I will just very quickly, I will go over, okay? So, okay, will I get this back if okay, no, it's too far away. So let me just, I don't need to remove the comments, okay? The way to implement this, okay, normally a variable is public. If you add one underscore before the
So we're not
name,
seeing we're not seeing your
Your
screen.
screen is not visible, sir.
okay, right, I stop sharing. Right, so okay, let's take this example. Okay, this variable right now, this is public. If I add one underscore sign, now this is protected, and if I add two underscore signs, now this is private. Okay, so this is the way to implement this. And what do we do after we implement it? Okay, how the accesses change, that we have studied, but this is the way to implement it. Okay, two underscores means private, one underscore means protected, and zero underscores means public. Okay, all right. Okay, we're done for today. You guys can leave.
Thank you, sir. Have a nice day, sir.
Excuse me, sir.
Yes.
Zero underscore is private.
No, zero underscore is public.
Zero underscore is public.
Yep. If you have no underscore, then it's public, which means anyone can access it. It's a normal variable.
A single underscore
Is
private.
protected, and two underscore is private.